Cable pull radius refers to the minimum radius around which a cable can be safely pulled without causing damage to the cable itself or its internal components. This is a critical consideration during cable installation to prevent potential problems that could compromise the cable's performance and longevity. It's important to understand why pull radius is a concern. When a cable is pulled around a bend that is too sharp, it creates excessive stress on the cable's conductors, insulation, and shielding. This stress can lead to several issues. Firstly, the conductors within the cable may stretch or break, leading to reduction in the cable's current carrying capacity or even a complete open circuit. Secondly, the insulation surrounding the conductors can be damaged, which may cause short circuits or ground faults. Thirdly, the shielding, which is designed to protect the cable from electromagnetic interference, can be compromised, leading to signal degradation or noise. The pull radius is typically specified by the cable manufacturer. It varies depending on several factors. 1. The type of cable. Different cable types, such as coaxial cable, fiber optic cable, or twisted pair cable, have different pull radius requirements. 2. The cable construction. The materials used in the cable's construction, such as the type of insulation and shielding, affect its flexibility and resistance to damage. 3. The intended use. Cables used in harsh environments or for critical applications may have more stringent pull radius requirements. To ensure proper cable installation and performance, it is essential to follow the manufacturer's guidelines for pull radius. These guidelines are typically found in the cable's datasheet or installation instructions. Ignoring these guidelines can lead to cable damage, reduced performance, and potential safety hazards. The pull radius is usually expressed as a multiple of the cable's outside diameter. For example, a cable may have a pull radius of 6 times its outside diameter. This means that the minimum radius of the bend around which the cable can be pulled should be 6 times the cable's diameter. There are several practical considerations to keep in mind when pulling cables to avoid exceeding the pull radius. Firstly, use appropriate pulling equipment, such as cable pullers and rollers, to reduce friction and stress on the cable. Secondly, lubricate the cable with a cable pulling lubricant to further reduce friction. Thirdly, avoid sharp bends in the cable path. Use gradual bends instead. Fourthly, pull the cable smoothly and steadily, avoiding jerking or sudden movements. Fifthly, inspect the cable regularly during the pulling process for any signs of damage. If damage is detected, stop pulling the cable and address the issue before continuing. It's important to note that the pull radius is not the same as the bend radius. The bend radius refers to the minimum radius to which a cable can be bent and left in place after installation. The pull radius, on the other hand, refers to the minimum radius around which a cable can be pulled during installation. The pull radius is typically larger than the bend radius. When installing cables and conduit, it's important to select conduit bends that meet the cable's pull radius requirements. Standard conduit elbows may not be suitable for all cable types, especially those with large diameters or sensitive construction. In such cases, it may be necessary to use wider radius elbows or to fabricate custom bends. The National Electrical Code, or NEC, provides guidelines for cable installation, including requirements for bend radius. While the NEC does not explicitly define pull radius, it does emphasize the importance of installing cables in a manner that does not damage them. Adhering to the NEC requirements for bend radius and following the cable manufacturer's recommendations for pull radius will help ensure a safe and reliable electrical installation. In addition to following the manufacturer's guidelines and the NEC requirements, it's also important to consider the specific characteristics of the cable being installed. For example, some cables are more sensitive to bending than others. Fiber optic cables in particular are susceptible to damage if bent too sharply. When installing fiber optic cables, it's crucial to use extreme care and to follow the manufacturer's recommendations closely. Another factor to consider is the environment in which the cable is being installed. Cables installed in harsh environments, such as those with extreme temperatures, high humidity, or exposure to chemicals, may require more stringent pull radius requirements. These environments can degrade the cable's materials and make it more susceptible to damage. When installing cables in these environments, it's important to select cables that are specifically designed for the application and to follow the manufacturer's recommendations for installation. In some cases, it may be necessary to use specialized pulling equipment or techniques to ensure that the cable is not damaged during installation. For example, when pulling cables through long runs of conduit, it may be necessary to use intermediate pull boxes to reduce the pulling tension and to minimize the risk of exceeding the pull radius. When installing cables in existing conduit, it's important to inspect the conduit for any sharp edges or obstructions that could damage the cable. These obstructions can increase the pulling tension and make it more difficult to maintain the proper pull radius. If any obstructions are found, they should be removed or smoothed out before pulling the cable. In addition to following the manufacturer's guidelines and the NEC requirements, it's also important to train installers on proper cable handling techniques. Installers should be aware of the importance of pull radius and the potential consequences of exceeding it. They should also be trained on how to use the appropriate pulling equipment and techniques to minimize the risk of cable damage. Proper training can help to ensure that cables are installed correctly and that they will provide reliable performance for many years to come. When dealing with armored cables, such as AC or MC cable, additional considerations apply. The armor itself can be damaged if the cable is pulled around too sharp of a bend, leading to a loss of mechanical protection for the conductors inside. Furthermore, the sharp edges of the cut armor can damage the conductors if proper care is not taken. It is crucial to use appropriate fittings and techniques to protect the cable at the point where it enters or exits an enclosure or raceway. In summary, understanding and adhering to the cable pull radius is crucial for ensuring safe and reliable cable installations. By following the manufacturer's guidelines, the NEC requirements, and best practices for cable handling, installers can minimize the risk of cable damage and ensure that the cables will provide years of trouble-free service. Remember to consider the cable type, construction, intended use, and environmental conditions when determining the appropriate pull radius. Use proper pulling equipment, lubricate the cable, avoid sharp bends, and inspect the cable regularly during the pulling process. And most importantly, train installers on proper cable handling techniques to ensure that they are aware of the importance of pull radius and the potential consequences of exceeding it. When planning a cable installation, always start by consulting the cable manufacturer's specifications. These specifications will provide detailed information about the cable's pull radius, bend radius, and other important characteristics. The specifications will also provide guidance on the proper pulling techniques and equipment to use. If the cable manufacturer's specifications are not available, consult with a qualified electrical engineer or cable installation specialist. These professionals can provide expert advice on the proper cable handling techniques and equipment to use. They can also help to assess the environmental conditions and to select the appropriate cable type for the application. When pulling cables through conduit, it's important to use a conduit bending chart to determine the minimum bend radius for the conduit. The conduit bending chart will provide information on the minimum bend radius for different conduit sizes and materials. It's also important to consider the fill ratio of the conduit. The fill ratio is the percentage of the conduit's cross-sectional area that is occupied by the cables. The NEC limits the fill ratio of conduit to prevent overheating and to make it easier to pull cables. When pulling multiple cables through a single conduit, it's important to use a cable lubricant to reduce friction. Cable lubricants are available in a variety of types, including water-based, silicone-based, and wax-based lubricants. Choose a lubricant that is compatible with the cable's insulation and that will not damage the conduit. When pulling cables through long runs of conduit, it may be necessary to use intermediate pull boxes to reduce the pulling tension. Intermediate pull boxes are small boxes that are installed along the conduit run to provide access to the cables. The cables are pulled into the pull box, and then they are pulled from the pull box to the next section of conduit. This reduces the pull-in tension and makes it easier to maintain the proper pull radius. When pulling cables through underground conduit, it's important to use a cable locator to avoid damaging the conduit. Cable locators are electronic devices that can detect the presence of underground cables and conduits. Before digging, always call 811 to have the underground utilities located and marked. This will help to prevent damage to the utilities and to ensure the safety of the workers. After the cables have been installed, it's important to test them to ensure that they are working properly. Cable testers are available in a variety of types, including continuity testers, insulation resistance testers, and time domain reflectometers. These testers can be used to identify problems such as open circuits, short circuits, and insulation faults. By following these guidelines, you can help to ensure that your cable installations are safe, reliable, and compliant with the NEC.